Hey everyone, good morning. My name is Yaarit, and I work on the Ceph Telemetry project. And today we're going to review the project and see why we do it, what exactly we do, and how we do that. So the free dictionary gives us the definition for telemetry. It quotes spaceflight, I like that, but it started earlier than that. And it defines it by the science and associated technology of the automatic recording and transmission of data from a remote source to a receiving station for analysis. And this is exactly what we're doing with Ceph clusters in the wild. Now the question is why we do that. Why do we care about collecting data from clusters out there? So as we all know, Ceph is an open source project, and we would really like to know how it's being used and to get some more observability into what's going on out there. So if we can tell how many clusters are deployed, exactly what versions they're running, their total storage capacity, what crashes happen in these clusters, what drives the clusters are using, and so many questions that some of them were even brought up during the various sessions that we had. So for developers, it's very useful to get feedback on what features are in use. You can see that every now and then we say we ask users for feedback, and a lot of it can be collected automatically. We want to know how users adopt new versions, how fast we upgrade, what CPU and drive models our users deploy. And one great thing about our telemetry is that we can learn about new bugs as soon as they happen with the crash data that we collect. Thanks to that, we can prioritize issues. I just noticed that the clock is not ticking, so I have no estimation for the time. So if someone can help me with the time, that would be great. The countdown is not working. OK, it's working. Awesome. Yes, so and once we discover the crashes and the bugs that we see in the wild, we can provide solutions, and we can actually verify that they work, that we don't see the issues being reported again. For users, they can validate their installations. They can look at what is common out there, what features are being used. If you're kind of worried of using a specific new feature, but then you see that it is being used by many other users, so you feel more confident using that. Users don't need to actively report issues or file bugs because everything goes to us, and we have a very detailed dashboard that we can look at, and we sync that to our bug tracking system as well. And then they can use this open data set in the bug tracking system and see if the issue is fixed and what version it's fixed in, so they can upgrade to. So exactly what is our telemetry? It is a manager module that was first introduced in Mimic, so 2019. I think Vito was the first developer on telemetry. He wrote that with Sage. He mentioned that yesterday. And ever since, we see a steady opt-in increase from an engagement from the community. So far, there are about 3,500 clusters reporting. And last Cephlacon, right after Cephlacon, we crossed the milestone of 1 exabyte, and right now we're around 1.7 exabyte. So maybe until the end of this year, we'll reach the 2 exabyte milestone, who knows. And the way it happens is that clusters basically phone home to report anonymized and non-identifying data about the installation. And you can see a lot of the aggregated data in our public dashboards. So the telemetry report is compiled every day by default from several channels. Each of them has a specific type of information. And we currently have 5 channels that can be turned on or off. So the first very basic channel is called the basic channel. It contains some general information about the cluster, like the Ceph and kernel versions, what's the cluster size, the utilization of the storage, how many daemons are there, and so on. If you opt into telemetry, the basic channel will be on by default. Then we have the crash channel, a very important channel to keep turn on. This channel contains very essential information about the crash, like the backtrace, so we can detect exactly where in the Ceph code the crash happened. And we collect some other information. We capture some the kernel version as well, and the Ceph version of the daemon, and so on. Then we also have the device channel, which is also on by default if you opt into telemetry. And this channel contains the drive health metrics, so smart metrics and NVMe metrics wherever possible. We have a couple more channels that are off by default. First one is the ident channel. So in case users want to identify themselves, and some users do, we allow to include the contact name, organization, and email. And we even sometimes use it. So if we detect a bug or a crash, that we suspect it could be a bug, we can actually contact the user if they left their details. And the last channel is the perf channel. We added that in Quincy. It contains a lot of performance counters and histograms, which are collected also every 24 hours. And this channel is also off by default. So how do we do that? Everything is built into Ceph, so you don't need to install any extra tools in order to report telemetry. It is a built-in Ceph Manager module. And by default, when you phone home, it's to our telemetry endpoint. If needed, you can also set up a proxy. Sometimes you need if you have all sorts of firewalls. But you can also configure telemetry to report somewhere else in case you want it to your organization. Very, very important to emphasize here. By default, our telemetry reporting is off. We do not report anything unless the user explicitly opted in. It's really important for us to emphasize that. Users can opt in either with a CLI command, the Ceph Telemetry on, or with a dashboard wizard. If you want to see what metrics are being sent before you opt in, you can do that with a preview command. And then you can look at that, and if it looks good to you, you can just opt in with Ceph Telemetry on command. If you're already opted in, you can just run Ceph Telemetry show all, and it will show you all the cluster data that we collect and the device health metrics that we collect. And then you can use Ceph Telemetry show to see just the cluster data, or you can even specify a certain channel to see just that data. We never contain sensitive information. We never contain pool or host names in our telemetry, or object name or content. We anonymize the report. So we assign a special UID for telemetry. It's specifically for telemetry. We never report the FSID of the cluster. And we also obfuscate the serial ID for the drive and we never store IPs on our backend. If we add new data, we ask the user to re-opt in on Ceph upgrade. So let's say you opted in Quincy, and then you upgrade even to a point release where we added new data in between, or to Squid, and you want to see whether there are new collections, you can run Ceph Telemetry diff. And then if there's something new, you can re-opt in with Ceph Telemetry on. And then if you want just to see whatever you're sending right now, you can use the collection ls command. We're really serious about privacy, so we're sending the cluster data, the anonymized cluster reports, into certain endpoint, and then the other device health metrics to another endpoint. Again, to even increase anonymization further. The way we compile the report is that the manager daily gathers the data from the different daemons, and it compiles one report for the cluster, and then the reports for the device health metrics, and it sends it to our endpoint, where we have an Apache server and a Postgres database, where we're crunching the data there, and we're presenting that in our dashboards. So if you go to Telemetry Public, Ceph.com, you'll see that there are about 1.7 total capacity, 1.7 exabyte of total capacity out there of Ceph clusters that are currently reporting, coming from about 3,400 clusters and a total number of about 200,000 OSDs. We can look at what versions these clusters are running, and we can see that the popular version right now, the most popular one is Reef. You can see that little purple line at the top, which is Squid, and you can see the annotation there. There's a mark where we started when we actually released Squid. But we can also tell how many, what's the capacity according to the different versions. So we saw that Reef was the most popular version, but capacity-wise, it's mostly coming, the highest one is Quincy, actually. So we can even have a greater breakdown. Here we can look at the point releases. So we can tell, for example, for Reef, according to the latest point release, which is 18.2.4, you can see this is the purple layer at the top, how users adopted it, and you can see that 18.2.3 basically goes down, and users are upgrading relatively fast. This one we already covered. We have also the heat maps in our dashboard, and the way to read the heat map is it's like a daily histogram. So you can basically see the distribution of clusters by their capacity. So we were curious, what's the majority of the clusters according to their total capacity? So right now you can see that there are about 300 clusters that report between 64 and 128 terabytes. So that's the most common cluster size that it is reported in telemetry. But there are some very big clusters up there as well. So you can see that at the top there are, I don't have the tooltip here, but there are, I think two, if I remember correctly, some very good, very big clusters that report several dozens of petabytes. which is really good for us to know. We also want to have some more observability into how certain features are being used, or certain configurations of the cluster. So recently we were curious about how EC plugins are being used in our community. So we can see that the JRazor plugin is by far the most popular one out there. And we wanted to have some deeper details about the plugin and see the different the breakdown by techniques. So this gives us a lot more observability into what is used by users out there in case we want to make big changes, in case we want to invest more in a certain feature or deprecate anything. We also added a dynamic dashboard to look at the distribution of the storage capacity utilization according to storage class and cluster size. So if you want to know how much the disks are utilized according to their storage class. For example, here we're looking at clusters that their maximum capacity is 1 exabyte. And we're looking at the NVMe storage class. So if we look at the 50th percentile, we can see that it's just 20% utilization. But if we look at the top one, is 84. It gives us some idea of how disks are being utilized. And we can also look at the same data for hard disks. I'll just mention here that we were looking at specific all the classes in each of the clusters. So we separated that by different cluster, different storage classes in each of the clusters. We also have breakdown of the data for Rook. So we saw in the previous slides that we have about 1.5 exabyte. And from them, we can tell for sure that 38.5 are coming from Rook clusters, about 600 Rook clusters. And we can see that most of them are coming from Reef. We have some more observability into Rook versions. So we can see exactly the Rook versions that these clusters are running, and the major Kubernetes versions as well. We can also tell how many OSDs and monitors are backed by PVCs. And I just want to say that we don't have, it's not necessarily accurate because some clusters do not report this data yet. So they might be Rook clusters that still do not send this data to telemetry. So we were talking about file store and object store earlier, and Neha mentioned it took 7 years to deprecate. We were curious to see, is it used out there? Is someone still using file store? So we looked at the data and we saw that almost, there are some numbers from Nautilus, but they were very low compared to BlueStore, and that gave us some more confidence to make the decision. So when you opt into telemetry, you're actually telling us, hey, I'm using this. If you want to deprecate it, maybe think twice, because it's still being used. We were also curious about BlueStore compression. So how many clusters are using BlueStore compression before we basically announced it? So surprisingly, there were clusters that have been using that, and they gave us some more confidence in the future. I want to talk a little bit about our crashes. So when we send our crashes to telemetry, we include some details that will help us identify the crashes, like the crash ID. And then we have the backtrace and Ceph version and exactly what daemon has crashed, some OS information, if there's an assert message, and so on. And we can look at that and combine that with other cluster information. So in case the basic channel is enabled. For example, what's the used capacity, or how many daemons, like the size of the cluster, and so on. And at our backend, we have a crash processor that identifies similarity among all these different raw crash reports, because there could be very minor differences between those crashes, but at the end of the day, it's the same bug, or it's the same issue. That processor supports multiple generations or recipes for the signatures. And this allows us to look at different versions of these crashes, basically. And then once the crash processor created the signatures that all those raw crashes map into, it populates the database. And then we have a Redmine bot that can query this database and basically sync this up with Redmine. So, sorry, it will search Redmine for the existing signatures. It will update an existing issue if it finds anything that already was reported by us or by a user. And then if it doesn't find anything, it will create a new issue. It will pick the right project. It will populate all the details. And then we basically have a tracker opened for a crash that happened automatically. We then update the issues with all of the essential information that helps us to look into that in the future, including a link to a dashboard that we'll see in a moment. This bot also helps us to identify regressions. So in case we already seen an issue that has been resolved, let's say that it has been resolved in Reef, but then we have new crashes that are reported from Squid, and we had identified that it's the same signature for the crash. We look at a tracker and we see that the issue is resolved. So the bot is smart enough to open a new tracker and link it to the previous tracker and say there are new crash instances of that resolved issue. We should take a look at that. So I mentioned the dashboard. The dashboard helps us to search by many different fields. So we can actually search by backtrace frames to see, to get some more observability of other crashes that might be related. I will not go throughout the entire list, but it gives us a lot of capabilities to get better understanding and observability of similar crashes. And then we can see the trends through different versions, which is very useful. So for example, here, this is a pretty recent snapshot of all the crash fingerprints or signatures that I mentioned according to the different versions. So we can see that already for Squid, there are a few crashes that are reported, and we can tell if they're new just in Squid or they happened in other versions as well. So our dashboard, and unfortunately, it's not dynamic here. It's just a snapshot. But we can look if you see the majors affected. Pull down is selected for 19. So we can see that so far there are about 450 crash fingerprints for just squid. Now, I'll just say that not every crash is a Ceph bug. It's important to note that. Sometimes it could be issue with hardware or compatibility with other tools. So it's not necessarily a Ceph bug, but we get more observability into that as well. So we can see that, for example, several crashes that were reported for squid also happened in Quincy and in Reef. So we can look at the specific bug and see exactly in what versions it occurred, or sorry, a crash. It's not necessarily a bug. We can see how many clusters were affected by it, when it was last reported and first reported, how many raw crashes we saw of that, and the daily, and we can see also a daily occurrences for that. So, oops, I missed a button, sorry. I mentioned that we can search according to a frame. So if you can see at the backtrace that we sanitized in order to create the signature, if we just click the op tracker frame, my bad, sorry, we can then see all of the different crash signatures that include that specific frame. And this can give us some even greater observability into other issues. And then again, we have a more detailed view of exactly the assert condition that we hit during that crash. And we can take a look at the certain raw crashes that were reported. So this is very, very useful for us if you report telemetry to let us know about new crashes that happen for whenever we release new versions. We have some examples for bug fixes for crashes that happened in the wild, and were reported automatically. Some of them even include backports. There's a nice example here of a tracker that was filed first by a user, and then the crash dashboard actually helped us to estimate when it first started, because the user reported that it was a snapshot, right, of whenever they saw that. But we actually saw that in telemetry, and we could get a broader understanding of when it first started. And then users also respond to the tracker that we open. They sometimes contribute fixes, which is awesome. So if you go to telemetry public Cephcom, you'll see the current dashboards that are online. And yesterday, someone asked me if we actually use the telemetry that you're sending. So I hope that that gave a good answer, that it's really, really useful for us, especially for the crashes information that we receive. Yeah, so don't forget what Ceph can do for you. Ask what you can do for Ceph, to quote Matt. You can turn telemetry on, and this will be super helpful for all of us. It's a win-win. Happy to take any questions. Yes.
Great presentation, by the way, Yaarit.
Thanks.
I have a question. So there's Sentry as well, and when I look at technology runs, and that's like the first link sometimes I click to see how many times has it heard throughout the weeks or months. I know telemetry can do that as well, the dashboard. I was thinking if, are there any distinctions in the features that you have on Grafana versus the one in the solution?
So I'm not sure that Sentry gives us a drill down according to occurrences of the versions and the different clusters, and then you can see the size of the cluster and their current versions, because sometimes a crash happened and then the user upgraded and now they don't see that crash anymore. So you can actually see from the dashboard the current version that cluster is running. So if the crash happened in Quincy and they upgraded to Reef, and we no longer see any reports from that cluster, it can give us a good estimation. Yeah. Topology, yeah. Yep.
Great information, right?
Thank you.
So do we have any information about how this Ceph installation was made? Was it a standalone installation or is something driven by Node.js or something like that?
So, is there a microphone that we can pass, or? Sorry. Oh yeah. Or
Yeah, so the telemetry, does telemetry capture any information about how the Ceph was installed? Is it an ODF installation or is it a standalone installation, something like that?
so we don't have. So, for example, we have Rook data, but for ODF currently we do not have this information. Yeah, this is something that we should be collecting.
Yeah, one more question there. You mentioned that we'll be having a list of daemons run. Does that also capture the RBD mirroring daemon running or not? That way we'll be able to know that how many clusters have already deployed the RBD mirroring, just in case.
So I'm not sure about mirroring, but we do know the number of daemons, the RBD daemons in the cluster. But I need to look into that. Yeah, we know how many RBD instances there are, but I'm not sure about mirroring.
That will be great. Thanks.
Sure. All right. We're only 10 seconds over time, so thank you, everyone. If there are any more questions, I'll be happy to take them.